Welcome to
Nay.
Do it.
Channel Everyone. This is episode 2026-0413. Okay, so today we are diving into a paper that asks a really fundamental question. Can our AI models actually reason about space, not just describe it, but act within it? JJ, you work on these big models. How big is the gap between what they can say and what they can do?
It's a fascinating and crucial gap, Isabel. We often test models by asking for a full solution in one go. Like, write me a path from A to B, but that's not how humans or robots operate. We take a step, look around, maybe backtrack. This paper introduces a test bed called Spatial-Gym to measure that exact difference.
And the results are pretty stark. The best model in their test, a massive one, solved only 16% of the puzzles. Humans, 98%, that's not a gap, that's a chasm. It tells me we are benchmarking the wrong thing. We test for final answers, not for the reasoning process.
Whoa, 16 versus 98. That's huge. So Spatial-Gym is like a video game for AI, a grid where they have to navigate.
Exactly, it's a gymnasium environment. Think of it like a standardized obstacle course. Simple 2D grids with walls and a goal. The key is they tested 3 modes. The usual one shot, give me the full path. Then step by step, where the model just says move left or move up and sees the result. And finally, step by step but allowing backtracking, undoing a move.
And here's a critical insight. The step-by-step format hurt the stronger models, their performance dropped. Why? Because in one shot they can plan the entire route globally in their mind. Forcing them to act step by step like a robot would have to constrains that. It breaks their ability to hold the full plan.
That's so counterintuitive. I'd think getting feedback after each step would help, like a GPS recalculating.
It does help the weaker models by removing formatting errors, but for the powerful planners it's like asking a chess master to only think one move at a time without seeing the whole board. It disrupts their strategy. They aren't truly reasoning asterisk in the space. They're reasoning asterisk about asterisk it from the outside, and then that plan falls apart when executed.
Another shocking find, models that could see asterisk the grid as an image did dramatically worse. 73% worse. Text descriptions worked better. This suggests they aren't building a true spatial mental model from the visual input, they're just kind of guessing.
So vision is actually a distraction here. That's wild. What about backtracking? Did that help?
It helped weaker models finish episodes. They could get unstuck, but it didn't improve their solve rate much. And the strong models, they almost never backtracked, even when they should have. They just plow forward on their initial, often wrong plan.
This points to a lack of meta-reasoning. They don't scale their effort with the puzzle's difficulty, and they don't know when to stop and re-evaluate. A human hits a wall, thinks, okay, that path is dead, and goes back. The model just keeps trying to go through the wall.
So what's the big takeaway for people building or using this tech? For robotics, this seems like a red flag.
Absolutely. If you're feeding sensor data to a model to control a robot, and it can't reason step by step in a simple grid, real-world navigation is miles more complex. We need to train and evaluate on this interactive, sequential decision-making, not just on final answer generation.
The hopeful note is that chain of thought, where the model writes out its thinking, still gave a 3 to 5 times accuracy advantage even in the step-by-step setting. So the reasoning process itself is valuable. The framework they built, Spatial-Gym, is perfect for using reinforcement learning to train models how asterisk to explore and backtrack. To learn the process, not just the answer.
So we need to teach AI not just the what, but the how. The step-by-step dance of figuring things out in real time. Mind the gap, indeed. Thank you, JJ. Thank you, Jiyoung.
Thank you.
Thanks, everyone.